All right, so let's get going. If I know last week you couldn't come, I hope you have watched the recording of last week. I actually quickly went over the prerequisite skills that was required for this topic, and I was a little rushed kind of because there was another uh, office hour coming up, not office hour, another meeting coming up at that time. If you have any questions when you watch that recording, please let me know. All the answers should be there. If you work it out, and you can check the answer within that same slide. If you haven't downloaded that slide, it's also, you can download it here. What's that called again? Scatter plot plus recursive plus explicit formula. So that is the slide that that I went over last week. Okay. So I know we discussed this. I'm just going to go straight to the content so that we can get covered as much as we can. In this, can you draw or anything? Touch on the screen? Or are you on the phone? Okay, you can. Okay, so I give you permission to draw. Okay, here's what I want you to do. We're gonna do some review. You study this univariate and bivariate data during in the content, and also you have posted something on the discussion, and actually reply to your discussion post. I realized you have some misconception about univariate and bivariate. You can go back and check on your discussion post for what I responded. And at this point, I want you to select a color that you like, blue or red. I want you to put a check mark on next to the items that represent bivariate data. Some of the item here doesn't belong to univariate or bivariate, so it could be, related to. Okay, your average cycle. Okay, that's good. That's good. Bivariate. Okay, we want to look at bivariate. I'm drinking my coffee to keep myself awake. Good job. It's hard to draw, isn't it, on this thing? That's why sometimes I like to use screen sharing when I work. I have many things to work it out. Anything else? Okay, good. Yes, I think you cover the three things that the most important for bivariate. Okay, bivariates are two variables, only two. There's no multiples. There's one thing that you mentioned on discussion post. There's multiples. There's only two data to collect at the same time. If you collect more, you are comparing only two things. Okay, two set of data. Whereas univariate involve only one set of data. Okay. So in this case, use the red marker, only mark those for univariate. There's something that's for neither of them, so I want you to just mark something. Okay, good job. Good job. Awesome. That's it. That's all you. Data that remain constant doesn't belong to any of these. It doesn't explain whether it's univariate or bivariate. Both data could remain constant or they don't remain constant. Okay, I put it there as a distractor. All right, good job. That was a good activity. All right, you have, before I move on, any questions on univariate or bivariate? During the quiz, you will be asked, okay, which one below is univariate? Which one below is bivariate? Or which, it might tell you, Mr. Jones is collecting data for science class on all his students. Is this an example of bivariate data or a univariate data? Or something else that's not even two of these words? So these are kind of questions you are expected to see. All right, now we are going to work on writing a function rules on recursive arithmetic models. Okay. Corey is working at the Best Device store. I made up the name. He earns $50 per day and additional $10 in commission for every computer he sells. What is a recursive equation that models this situation? So when we talk about recursive, we're talking about an equation that requires previous terms to calculate the next term. Okay? So let me plug in. Things that require previous term, we usually use a little symbol A with a subscript n to start writing the equation. So let's see how well I can write on this today. So we start with an. Okay, so this is a current term. Okay, current term. Require the previous term to write to calculate the next term. Okay, so we'll see. Before you calculate, write your recursive rule, you need to know, okay, what is my base earning, or what is my initial value? What do I start with? Okay, what is your A0? So what is the A0 in this case? You can type in the chat box. Okay, good. You already did. And how would he earn more? By adding how many? So we start with 50. Okay, and the computer is what we don't know every day is how many computer he sells, right? But let's say 0 is if he sells 0 computer. 1, this is n, okay, n. And 0 is selling 0 computer, and is 1 selling 1 computer, 2 selling 2 computer, 3. So when n is 0, he only earned $50 that day. He sell nothing here, just work. And then if he's selling 1 computer, he earned 50 plus 10, right? If it's getting too hard to write, I might move to a desktop sharing. And then he gets 60. And then he's selling 2 computers, 50 plus, it will be 60 plus 10. It's not easy to write here. Well, you get the idea, you add 10 each time, okay? But adding from previous value. This is a recursive rule. You're adding from a previous value. Oops. Okay, so here is a recursive model. An is the current term equal to an minus 1, which is the previous term, okay, plus 10. where a, which is the initial value, a sub 0 means initial value is 50. Okay? So this is recursive. So if n is 1, if he sells one computer, then you will get a1 equal to a1 subtract 1 right here. 1 subtract 1 is 0, which is the 50 plus 10. That's how you get 60 for the second one. This is a recursive model. Any question on, do you understand how all this notation and how this equation become this way? Hold on. You get a little, we might have to do some more. Okay. You can speak if you want. I give you a microphone. If you ask questions verbally, it's easier for you. You're welcome to. So, okay. Let me see. I might have to write it on the So, how do you check whether the answer is correct? This is always a question when you do quiz. How do you check whether the answer is correct? I am going to do plug in some terms, and you know, okay, but you have to know how to plug it in. I'm going to do a screen sharing because I can write better using screen sharing. Okay, so just give me a minute. You see the same slide, except I just do it on my screen. Can you see my screen? It has the same slide. So, to know whether this is correct, we know when n is 0, where n is 0, 1, or 2, meaning he sells 0 computer, 1 computer, or 2 computer. Okay, so we know whether how much he will earn. If he sells 0 computer, he's going to earn 50, right? If he sells 1 computer, he'll earn 50. So this is when when n is 0, what you got here is A0. This is A0. And when n is 1, what you're calculating is A1, A sub 1. Okay? So when he sells one computer, he's earning 50 plus $10, right? So A1 is actually 60, right? You got that? And then if he sells two computer, you actually using $60 after you use $60 plus another 10, right? So where do you get 60 from? 60 is from a previous one, right? From a previous term, you bring the 60 down, and it's actually A1. So 60 actually A1 plus 10. And that gives you A sub 2. That's called recursive. You're using a previous number to calculate the next number. So I'm gonna calculate when n is 3. You are actually using the previous term, A2 plus 10, and your A2 is 60 plus 10 from up here. So you get 70 plus 10, got 80. So your A2, A to the sub 3 is 80. Do I Do you understand it better now or even more confused? Okay, good. So you know what you're gonna earn because this is a simple situation, and when you plug it in, the n is how many you are. You need to know what your n0 means. Okay, when we are working on our assignments, the ball bouncing assignments, when you're writing a recursive models, um, many people doesn't know what the n equals 0 means. Okay, so that when they write the models, it is not that accurate. So let's look at the next slide. Is it the next slide? Oh yes. So which of the following is a function rule for the given recursive equation? So another kind of questions you might come across during quiz is this kind of questions. It gives you a recursive equation. It asks you an explicit rule, or they call function rules. Okay. So for recursive rules, the difference between recursive is for recursive you are required to get a previous terms, maybe one previous or two previous terms to calculate the next terms. Okay, that's called recursive. We are recurring using the previous term. For function rule, you are not required to have a previous term. You can calculate any term anytime you want by just plugging in the term number. That is the function rule. There is a need for recursive rule and function rule in different times. And function rule, recursive rule allows you to see the real pattern. Like in recursive rule, you see that that every term is adding 10. Like you can see it is adding 10, right? Plus 10 each time, plus 10 each time. And this plus 10 is also shown in the what's it called, the equation, the recursive equation itself. Whereas function rules, this is not always obvious. We are working with simple equation now. It may be obvious, but it's not always obvious. Okay, so here's the recursive rule that we just came out just now, right, from the previous questions. And when we know when n is equal to 0, an is 50. When n is 1, an is 60. When n is 2, an is 70. When n is 3, an is 80. Like we calculated it just now on the slides. Okay, so now you're given choices of function rules, and you want to know which of these is matching with the input and output. Remember the word input and output for a function? You learned this, I guess, middle school, 9th grade, 10th grades. So the input is the n, the output should be an. So which of these, so your n in this case will be your x. When you plug in x equal to 0, you get 50. When you plug in x equal to 1, you get 60. When you plug in x equal to 2, you get 70. Choice 1, 2, or 3 will give you that input and output that matches this table. That's what you should figure it out. Choice 2. Okay, let's see. So when 10 times 1 plus 50 give you 60, okay, check. 10 times 2 plus 50 equal to 70, check. 10 times 3 plus 50 equal to 80, check. Awesome, so you found it. And the question in the quiz are they are asked the same way, but they're not the same questions. Okay? So are we good? How do you come about to you will not be given the table, but you have to know how to figure out how to get recursive rule to come up with a few terms so that when you plug in your function rules, you can check it this way. Okay? Are we good with this? Okay, so now you try this. Okay, it's a similar kind of questions. Oh, I have the answer out there. No. Let me see. Okay, you try this. This one doesn't have answer. Type in the chat box. So we're asking the function rule. We're not asking the recursive rules. Good job, I think. Let's see. Oh yeah, I have the recursive rule here. It wasn't even the correct answer. But you did it right. You did it right. Okay. So now you write the recursive rules. Just now you did the function rules. I corrected my error. It should be updated in the link that you would download. Yes, n minus 1 plus 5. But you always have to start with an equal to an minus 1 plus 5. And this a sub 0 is incorrect. This is supposed to be 15. This is supposed to be a sub 0, supposed to be okay, meaning it's $15. And sometime you could actually say, okay, a sub 1 is oh, this pen is driving me crazy. 20. Okay. Sometimes you could tell people what is the a sub 1. The goal of this additional information is so that you know where to start with. You know, what number do I start to start adding 5? Okay. Great job. All right. So now we have been working on arithmetic sequences, recursive model, and function rules. Now we are going to work on a little bit on exponential models or geometric sequences. How do you use this recursive form to find the next terms? These are very basic. Do you need me to review, or you can go ahead and try it? Tell me what's the answer for A and B. You can even write on the board. You can write it. I know it's hard to write, but you can write. Or type. You can type. You can like use the little word, type it out. Okay, review. Hang on. I need to write on a screen sharing because it's hard to write here. Okay, so recursive to calculate the next term using it's the same way. You know, Tn is a current term. Except instead of using a, they're just using t. They can use anything actually, but they can use t or a or b. But basically, it's the same concept. N is a current term, and you see a Tn minus 1, meaning it's a previous term. Okay, n minus 1 term. So given T1 is equal to 6, so when n is 1, the Tn is 6. Okay, T sub 1 is 6. Okay, so when n is 2, the formula said T2, I'm going to multiply 2.5 to my T 2 minus 1, right? Because the n is 2, 2 minus 1 is 1. So 2.5 times T1, meaning 2.5 times the number from before. Number come here, which is 6. And that gives me this 2.5 times 6. 15. That's T2. Oh, yeah, you got it. All right, so now when these T3, same thing, you got now n is 3. N is 3. Plug it in. N is 3. 3 minus 1 is 2. Basically, you just use the previous number. So 2.5 times 15. So you do the calculation. It's faster. Okay. You can go ahead and do T6 too. Good job for T4. You got it. So T4, Amani got 93.75. Same methods. You're using T3, which is 2.5 times 37.5. And T6 is T5 times 2.5. And you should get 585.9. Okay? 9375, but you can do 9 or 94. Depends the choices that you have in your answers. Good. Got this part. Let's see the next one. You're good with this? Awesome. All right, so now we are going to work on writing a function rule for recursive exponential models. Example of word questions, word problem. A population of ladybugs started at 10 ladybugs and is growing at a daily rate of 3%. Means it's going. It's an exponential growth. Write a recursive equation to model the population of ladybugs on a given day, n. What is the starting number? That will be the starting number. That will be the a sub 0. Okay, in this question, what is a sub 0? You need to find that out. Good, you got that. So a sub 0 is equal to 10. Because the ladybugs are growing, the rate will be more than 1, which is r has to be greater than 1. If the r is less than 1, meaning things are decaying or slowing down, okay? Because if you multiply R is the number that you multiply to get to the next number. If you multiply anything that less than 1, you are actually dividing it, which is not growing, it's decaying. So every additional day there is an additional 3%, or make sure you change the percent to a decimal number. Okay, you're moving 2 spaces to the left to make it decimal number. So R is equal to 1 plus 0.03. The 1 is meaning is whatever is existing, right? Well, the existing is always 100%, and then you grow 3%, so you add another 3%. And then after that, there will be another, the new one will be a new, you will consider that 100%. So every day you're adding 3% based on whatever existing ladybug that you have. So the general formula for exponential growth, recursive form, recursive, we're working on recursive, is to get to the next term, you multiply by the rate. And we figure out the rate is 1.03 because 1 plus 0.03 is 1.03. And the a sub 0 is 10. Okay, so here at the black part, here's our recursive formula. an equal to a sub n minus 1 times 1.03. It's very important. The second part is very important, where a sub 0 is equal to 10. Okay. If you don't have the second part, your equation is not complete, because nobody know what number to start with, right? You cannot go anywhere. So here's the extension. This is what I want you to do. Any questions so far, Amani, before I move on? Good. So before I move on, I want you to try this extension. What will be the population of the ladybugs after a week based on this recursive formula? uh, the n is 7. Not n minus 1 equals 7. No. So you have n equal to 7. So here's n. Here's an. When n is 0, you got 10. When n is 1, you got 10 times 1.03. When n is 2, you got 10 times 1.03, then times 1.03 again, because it's the second day. What is a? This a is just a like when you write a function rule, y equal to it's not, it's just a alphabet to represent that this is a recursive formula. So 3, you got 10, 1.03 times 1.03 times 1.03 3 times. and then 4, then you multiply it 4 times. Yes, that's correct. That's the correct answer. 12.3 is the correct answer. So at A7, you have about 12.3 ladybug. But you can't really have 12.3 ladybugs, right? So you would just say about 12 ladybugs. Depends how. So you're good with this? Okay. Let's save this. All right, next questions. The chart below gives the recorded height for each bounce of a ball. If the original height of the ball is 65 inches, no, it's 50 inches. Okay, because my table have 50 and I have 65 here. 50 inches. Estimate the rebound percentage for each bounce of the ball. This is similar questions that I got from your assignments. They also will ask it in a quiz. You might get it or you might not. Remember how to calculate rebound percentage? You did the assignment. It was pretty good. The first 2 pages. You want to explain it, or you can just tell me the answer? Yeah, current height divided by previous height times 100. That's great. So based on this table, can you tell me what is the rebound percentage of this ball? If the first, you would actually calculate the rebound percentage on each of them. Like you do 24 divided by 50 times 100, and you got 1 rebound percentage, right? It should be something at 0.48. You do it for each of these, and then you total it up, and then you add them up, and you divide it by how many, like 3 data that you got. In this, let me see. Yeah, I'll let you write on it. Let me get to that page. Right here. You can write on it now. Are you trying to write? I'm letting you write. Are you able to move your pen? Let me see. Oh, yes, you're writing. %. Good job. So you average it up. They're all 48%. It should be. Right, great. So you are good with these questions. I hope you don't make mistake when it comes to these questions. All right. Here's similar questions from the assignments. Many students are I modify this. This is not exact questions. Have problem with questions I posted here. I kind of simplify the wording. We're gonna work on this because you might come across similar question for the quiz, and students who haven't done this assignment can use this to refer to this before they work on the assignments. All right. Tennis balls are sealed in a pressurized container to maintain the rebound percentage of the balls. A tennis ball has a rebound percentage of 55% when it's taken out of the pressurized can. Suppose a new tennis ball is dropped from a height of 3 meters onto a tennis court. Write the function rules. Explicit formula. So we need our explicit formula, meaning and we know this is the R that we have is the rate is 55% or 0.55, right? Okay. Would you like to try to write the function rule? You can write on it. Yes. So here's a little reminder on a generic formula for, you could write AN equal to A sub 0 R N or N or N minus 1 depends on the situation. Um, and in this case, height, is it a exponent N minus 1? Okay, it was a good try, but I just have a question. If you were to put H in the parenthesis here, what the H would be is if it's a formula, it's an explicit formula. What do I plug it in? Because I'm supposed to use a formula to find out the height of the bounce, according how many bounce. My N is my number of bounce. So it was a good try. Let's review some formula, okay? It's not easy right here. So AN is the height, okay? Height of the nth bounce. Height, let me type on this one. height of nth bounce, okay, is equal to the a sub n. Height of nth bounce is a sub n. So if I say bounce number 1 will be a sub 1, bounce number 2, the height of bounce number 2 will be a sub 2, height of bounce number 3 will be a sub 3. Okay. Yeah, thank you. I will switch back. It's easier to write over there. Many teachers encounter this problem too, but was it hard for you to write too? Just curious how it works on the other side. So in here, we know to write explicit formula, the generic formula for a recursive geometric sequence is an equal to, we need the initial value, we need the rate, and then we need an exponent. The exponent could be n or n minus 1, depends on your situation. You always have to settle your formula and then check whether it works. Okay, so an is height of nth bounce. Okay, and a sub 0 is the initial drop height. In this case, is 3. Okay, and R is the rate or the bounce rate, rebound rate. Oh, let me write it. Rebound rate. Okay, so initial height is 3, and the rebound rate is 0.55. And then I want to know whether I used n or n minus 1. I know after I drop it one time, right? When my a is equal to 1, I know I do 3 times 0.55, right? Because that's how do I calculate the first bounce, the height of the first bounce. So now I know I need to use n equal to 1 because that's how I calculated the first bounce. When I do the second bounce, I do 3 and I use the previous number, and then I multiply by 0.55 again. Whatever you got from first bounce, you multiply by 0.55, so you end up with 2 as exponent. So to get the height of second bounce, a sub 2, my exponent will be 2. So that solves my inquiry. So I'll use a sub, the exponent is n instead of n minus 1. You always check this like that so that you know, okay, is my formula correct? Don't just blindly follow the generic formula that teacher gives you. So we have this as our formula. Okay. Oh, what is the height of the fourth bounce of the new tennis ball? Now it's easy. We did a hard job. You just plug it in. Okay, you can calculate that. 275 or 0.275. 0.275. Okay. Yes. So the bounce of the ball should get less and less. When you calculate your the height of the bounce, the more bounces, the lower the ball should be bouncing. If your number is getting higher, something is wrong in your formula. Okay. The third question, tennis balls are sealed in pressurized container. Okay. Third question, how many times does it bounce before it has a bounce height of less than 20 centimeters? So just now we have a formula. We have a previous slide formula. AN equal to 3 times 0.55 N, right? So because now they want to know the height, when is this going to be less than 20 centimeter? 20 centimeters. So AN equal to, instead of, I know 3 meters is equal to 3 times 100 centimeters. So it's actually 300 centimeter. So if I change it to centimeter, my calculation will be easier. Okay, so when is this less than 20? Now, there are two ways you can approach these questions. You can approach by plugging in numbers. You know just now at the fourth bounce, it was already at 0.27 something. 0.27 something meters, if you multiply by 100, is 27.45 meters. We know at fourth bounce, a fourth is 27.45. So I know if the more it bounces, it's going to be less. So I'm going to try to see if I plug in 5 in the end, whether it will be less than 20. 5 bounce, you calculated that. What do you get? It's 300. All right. So at fifth bounce, actually, it will be less than 20. So you will say, how many times does it bounce before it has a bounce higher less than? How many times does it bounce before it has a power? So at fifth bounce, okay, is the answer. What is the total vertical distance that the ball travels after 4 bounces? Okay, this is another question. So at first bounce, so remember your ball bounces go up and down, right? It's dropped from 3 meters height, it come down, so this is 3 meter. And then it bounce up for the first bounce, it come back down, right? This is the first bounce. And then go up again the second bounce and come back down. And then third bounce, come back down. Third bounce, and then fourth bounce, come back down. Now every bounce they go up and down. So if the bounce height, let's say the fourth bounce height is 27.45, then it also has to come back, travel 27.45 height before it bounce again for its fifth bounce. This is second, third, fourth. Right, this is first, second, third, fourth bounce. So everything that you calculate, the height it has to multiply by 2. So this is 27.45 centimeter, and it's 27.45 centimeter. So you need to add your initial height where's my pen? Plus 2 times a sub 1 times 2 times a sub 2 plus, sorry, not times, plus 2 times a sub 3 plus 2 times a sub 4 to get the total number. Okay, I set it up for you. That's how you should do it right. Okay, any question on this? Because it's gonna take a lot of work to calculate. I'm not gonna do it now. Yeah, because it's 59 and I want to make sure I cover things. Let me see. So another kind of question you can come across is they give you a function rules, and you will just try to plug in the number to get a sequence that matches these rules. Okay, do you think you can do this? We kind of did multiple times question like this. Give me a yes, and then I'll move on to the next slide. Great. This is a writing of another function rules. Again, this is exponential model. You know it. Exponential when it tells you it's growth by the rate instead of by how much. Okay, it's a rate. The percentage, usually those are exponential equation. You don't know, the question is not going to tell you this is exponential question. You identify it by looking at the rate. Okay. Also, because it's multiple choice, you can look at the choices of answers to give you a hint. The initial value is 3, and because the 50% increase, the rate will be 100 plus 50%. Some mistake here. It should be 150. I don't know why I write 120. Must be too early in the day. Okay, it's 150. And then you plug in a 1.5 into the equation. Initial value here. Always start with the initial value as 3 and then the rate with the exponent. Again, do you need to subtract 1 on the exponent? You need to plug it in and test to see whether it matches the value that you're supposed to get each time. You got this one? Good. And a quick review of rate of change. If you have a linear function, the rate of change is constant. If you have an exponential growth function, the rate of change is increasing. So the graph is increasing like that. Okay, for linear function is a straight up, straight down. For exponential decay, it's decreasing. So so this is the generic idea of comparing rate of change. You'll be asking straightforward questions like that. Okay, you have a linear question. What is the rate of change of certain function? And then you will just pick the right one. Okay, or some word question too. Okay, so the next chat session will be next Monday. I will discuss the next two parts of this quiz, and also other question by request. On the homepage, let me see. Hang on. We're almost done, almost done. One last thing. One more minute. I'm almost done. Where are you? Okay. All right. So on our homepage, I changed out the bulletin board. Tip of success, and you see this Voki thing, this little smiley face that have long eyelashes and thick lips. Here you can click. If you have any questions on this course, you can click here and tell me. When you click here, you bring you to a form, and you tell me what's your name, what is the phone number, email, and what topic do you need help, and I can work it out in the next chat session, or even email you if that is if I can do that within my time. And down here under user links, I post, other than a welcome session and a synchronous session that we usually do every week, I added a section called tutorial. That section, I will have more tutorial added here, meaning if I see some skills that student might need, prerequisite skills, I will add a tutorial there, either a video that I make myself or video that I found, or even a link or a page that can help students. Okay, so here's that is something I need to share. And that's it for tonight. I appreciate you to be here. I always enjoy your company in the chat sessions. I hope this session helped you to prepare for the quiz. If you have any questions, email me. You too. Have a good week and have a good night. Thank you for